This presentation is delivered by the Stanford Center for Professional Development.
So what I want to spend a little bit of time talking about today, or actually a lot of time talking about today, is thinking about data structures, building large-scale data structures. And we began to talk about this a little bit before the break, and it's been a while, so we're going to review it a little bit and kind of build up even more. But one of the things we talked about in the past, right, was a lot of what computers do is they manage data. They manage lots of data. And in fact, I would venture to guess that there's a whole bunch of applications out there that manage a whole bunch of data about you, but then you may not have actually thought about all the data that they actually manage. And so some of the things that actually come up were, for example, online stores, right? Anyone actually bought anything online? Just wondering? Yeah, there's a huge amount of data that's involved with that. Not only the particular transactions you make when you buy something, but keeping track of aggregate transactions, figuring out things like people who buy product X also tend to buy product Y, right? All of that is data management. And what makes many of those companies successful is they just do a very good job of managing their data. Okay? There's other things like, oh, I'm almost frightened to ask, but social networks, like, oh, Facebook or MySpace or Orchid or Friendster or LinkedIn, or you could just keep going. I don't know how many of those things are now. Anyone on a social network? Just wondering? Yeah, many people. That's good, because your next assignment's going to be to implement one so you can see what they're actually like, but that'll be coming in a couple days. They're not that hard, really, but what it is, it's a data management problem, right? And it keeps track of things like who you are and information in your profile in the social network and who your friends are and all that happy news. Or you know, even things like our old friend web search, right? There is a huge amount of data you need to keep track of to be able to do web search, right? So all these things are all about managing data well. And so part of this class, right, is you've gotten a whole bunch of experience in terms of building up code and different kinds of classes and doing nice things with user interfaces and the whole deal. And one of the things that we need to spend a little bit more time on is talking about how do you manage lots of data and then do something interesting with that. Okay? So here are some principles to think about. If we think about good software engineering, some of the principles of thinking about data kind of in the large. Okay? When you think about keeping track of lots of data, one of the things you want to think about is the information you want to keep track of. What are the nouns you want to keep track of? And you're like, Maron, the nouns? What do you mean by the nouns? Let's say I was writing an application that was an online store to keep track of, oh, let's say music. And so one of the things I would want to think about is what are the nouns that are associated with music? You're like, okay, now you're getting really weird. No, it's pretty simple, right? Things like a song, right, is a noun that's associated with music, or an album, or an artist. Right? And so what you want to think about is the things that are the nouns in the domain that you're dealing with oftentimes end up translating into what your classes are. So you may end up having a class that keeps track of information about a particular song, or a class that keeps track of information about a particular album. So the good linguists out there tell me we have not only nouns, but we also have verbs. Not unless you happen to be talking to my son, who seems to only have nouns, but that's a different story. And he loves gerunds, by the way. But you're like, why are you telling me this? Just because it's fun. Because I just spent a whole week dealing with it. In terms of verbs, these are oftentimes the methods that are associated with your classes, right? So when you want to do something, some noun takes some action, which is a verb, which is some class has some method that operates on that class. So at an abstract level, that's what you want to think about in terms of high-level principles of design. Now, there are some other sort of more concrete things that you might want to think about. Things that have to do with what are the characteristics of the data you actually want to store. So one thing that comes up oftentimes is thinking of the notion of having a unique identifier. What do I mean by a unique identifier? All of you have unique identifiers, whether or not you like it or not, as a result of being at Stanford. Your Stanford University ID number is a unique identifier for you at Stanford. Every student has an ID number. Okay, so it identifies you, and it's unique. No two students share the same ID number. So you get issued this number when you show up here, and you have it for life. When you leave, it's still with you. I know, I left, I came back, I had the same student ID number. It just exists, and this uniquely identifies you. And in different cases, you might want to think about what are unique identifiers, right? So in some cases, for example, if you had a social network, you might consider the names of people in that social network to be the unique identifiers, or say the names of their profiles, for example. In other cases, you might have something different. If you're managing a store, you might have some ID number, like for books, an ISBN number, number. Or if you're keeping track of music, you might say that the combination of the song's name and the band that plays it is a unique identifier for that song. So in some cases, the unique identifier can be a combination of things. But if you think about your data having a unique identifier, that also gives you some insights about what kind of data structures you might want to use to keep track of certain things. Another unique identifier that some of you have already grappled with is, say, in NameSurfer, right? If you think about the data in NameSurfer, what's the unique identifier there? Name, right? Name is a unique identifier, and for every name, you have some list of values associated with it, which was the rank of that name over the last century in terms of how popular it was for names. But every name, well, I shouldn't say every name has some value associated with it, but every unique identifier in the system has some value associated with it, and only one set of values. And so the important thing to keep track of there is when you actually are doing your NameSurfer assignment, the fact that this thing is a unique identifier can potentially help you keep track of the data that you're using, and we'll sort of go into some of that as we go along in the class. Okay? So some other principles we can kind of think about in terms of designing a data structure. So in terms of actually doing the design, there are some questions you want to ask yourself. And the questions you want to ask yourself is, are you keeping track of some collection of objects? Right? So there comes some collection of objects or data that you want to have. And if you have a collection of objects, say in an online music store, you might have a collection of songs that you want to keep track of. This word should be a tip-off to you that perhaps there are some interesting collections that exist in Java that would be a way of keeping track of that information. Now, it need not be in Java if you're programming in some other language, but the fact that Java has something called a collection, the reason why they gave the name collections to a certain group of stuff is because they're used to keep track of a collection of objects. And the question that you ask yourself then is, what collections do you actually want to use? Okay? So with that said, what we can do is spend a moment, and it'll be a brief moment, revisiting the collection hierarchy. Right? You've seen this picture before, but I'm just showing it to you again because the last time you saw it was like 2 weeks ago, which is a lifetime in a quarter, right? If you think about 2, it's like a fifth of the quarter. You're like, oh, what was I doing 2 weeks ago? Was it breakout? Was I learning println? No, it wasn't that long ago. But what you were learning about a little bit was collections. And so there were some collections, for example, like an array list, that going all the way up the chain of the hierarchy is itself a collection. Or there were other things, for example, like a hash map. And a hash map, if you said, hey, I have some hash map, the set of keys in that hash map ends up actually being a set, which happens to be a collection. Okay? And so what you want to think about are, I have different things I can keep track of. Like an array list is one way to keep track of things. A hash map might be another way of keeping track of things. When is the appropriate time for me to use one thing versus another? And so when you want to think about the appropriate time of one versus another, is you want to think about what are the methods that a collection provides to you. And it turns out all collections that implement the collection interface, like the array list or the key set of a hash map, have all of these properties. Okay? And some of them you've seen them before, but just to review, you can add a value, right? So this is a parameterized value type. Like you can have an array list of strings, and you can add some value to it, and it adds it to the collection. And little did you know, or maybe you did know, but at the time we didn't really care about it, was it returned a Boolean. Most of the times we just discarded the Boolean, we didn't care about it. But it actually returned true if the collection changed. So in an array list, it always returned true, because when you were adding a value, it didn't care about duplicates. It would always just add them to the end and always return true. Some collections, like sets, actually don't allow you to have duplicates. So if you try to add something to a set that already has the value you're trying to add, it will not change the set and return false, because it says, hey, I already had that value, nothing changed. A couple other things that you should know about. Most of these you've seen. Remove removes the first instance of an element if it appears and returns true. If the match is found, it returns false if it didn't find anything to actually remove. And clear basically just sort of nukes the whole collection. It just says, get rid of everything in the collection. I'm done with that. Right? The collection is dead. Well, actually, the collection's not dead to you. It still exists. It's just an empty shell of what it was before. There's violins playing in the background. Right? And then size, you can get the size of the collection. You've seen this. You've probably used a lot of these before in your programs. Contains, that's an important one, right? You actually want to see if a collection contains some particular value. If a collection is empty, and here's one that's sort of interesting that we talked about a little bit, but we didn't actually talk about the fact that a collection, or all collections, can give you one of these. All collections can give you an iterator. So we talked about, for example, having an iterator over the key set of a hash map. That's something we did before. We said we had some hash map that, let's say, mapped from strings to some other strings. And we wanted to say, hey, what I want to see is get a set of all the keys, and I want to iterate over all those keys. That's great. You can do that, and that's perfectly fine. When we used array list, we always had like a for loop and said, oh, from 0 up to the size of the array list, do something. But if we actually wanted to, we could have an iterator over the array list, and this would give us the elements of that array list one at a time. So because an array list is a collection, it can also give us an iterator. And that's just something to keep in mind, is that there's common patterns that get used in programming. One of the common patterns that gets used is what's known as an iteration pattern, which is you get an iterator over some collection, and you just go through and do something like print out the values for every element of that collection. And if you want to write it in the most general case, you don't care if that collection happens to be the key set of a hash map or an array list or whatever. You just say, hey, you're a collection. Give me your iterator, and I can go through all your elements one at a time and, for example, print them out. Okay? So those are simple patterns that we get into. Now, you're like, okay, Maron, that's fine. You told me some design principles over here. You told me about some collections over here. Show me something concrete, like put it all together. So let's actually put it all together. Okay? And we'll do a little example, which is going to be an online music store. And because many names for online music stores are already taken, our music store is going to be called FlyTunes, because there are tunes that are fly. You know, like, yeah, Maron, you just, when you're like in your mid-30s, you just can't be that cool. But trust me, it is. Okay? So we're going to make a little store that just keeps track of music and albums and that music, and actually lets us keep track of prices of information and prices. And so what we want to think about is what are the things that we actually are going to do in that store. Okay? So one of the nouns of that store is going to be a song. Okay? So a song is some basic thing that we're going to sell. This is what we want to be able to do with the song. Now you would say, well, what does that mean? Do I have some method called sell? If we're doing inventory management, we might not actually have a method called selling a song, but we might, for example, want to add to our inventory to do things like add songs. And similarly, songs oftentimes are put together into albums. Okay, so we may also want to keep track of albums and do things like add albums to our inventory. Now, the interesting thing with an online music store that differentiates it from, say, a physical music store is you can do interesting things, right? You can actually have songs that are not on any albums, and that works, right? It's kind of like thinking of a single, right? When you go and buy a single somewhere, in the days of yore, you could actually buy a little record single and add 2 sides on it, so you got 2 songs. So there wasn't really a notion of a real single. I guess now there's like CD singles, but who wants a CD single when it comes down to it? You can get songs that are on albums, and at the same time, you can have the same song be on multiple albums, right? That always happens. There was a band, I won't mention their name, but I remember from the early 80s, that had 2 albums. They had their first album, and they had their best of album, which was like half the songs from their first album. It was just like anything you can do to milk the consumer. But basically what that meant was songs can show up on multiple albums. Okay, so we want to begin to think about how that might actually affect our design. Now, if we think about putting some information together, right, nouns become our classes. So if we're going to have song as a noun, we're probably going to have some class song that's going to keep track of all the information associated with a song. And so just for the sake of brevity, I'll tell you what information is going to be associated with songs that we care about in our store. There's a notion of the name of the song, the band or artist that performed that song, and then a price, because we're going to allow for songs to be sold individually. So individual songs as opposed to whole albums have prices. Okay? And you can think about these things and think of, oh, what data types do you want to have for them, right? So what data type makes sense for a name, for example? String, right? Or if you want to have a band name, this would probably be a string. Price is always an interesting one. You could sort of say, well, Maron, there's multiple things that could be. I could have it be an int, for example, if I was going to have it be the number of cents. I could have it be, in the simplest case, I'm just going to have it be a double, even though we know there isn't fractional money unless you're a banker, in which case there is fractional money, but we won't talk about that right now. It was just like Superman 3. Anyone see that movie? No, it's not worth watching, trust me. But fractional money does exist outside of movies, bad movies in Hollywood. So that's the information that we want to keep track of for a song, and then we want to think about what are some of the things that we want to be able to do with relation to those songs. The other thing we also want to think about is our friend, the unique identifier. Is there some unique identifier for a song? And this is one of those things where you really need to think about the application that you're using, what assumptions you could make. We might like to say that a name is a unique identifier for a song, but unfortunately there's many songs that have the same name. Okay? But I would venture to guess that the combination of the name and the band would perhaps be a unique identifier for a song. The only thing is we don't have one string that we keep track of that has name and band in it. So that's another thing that we need to think about, and we'll get into code when we get into code, that we need to think about for the design of that particular object. The other thing that we think about is what changes in an object during its lifetime and what doesn't change. Right, so if I have a song, its name and the band that made it for a particular song, right? Some band can go and cover the song later on, but that's a different song. The name and the band name don't change for a song. But hey, it can go on sale, and I can jack up the price at the holidays and all that kind of stuff. So the price is something that's malleable. So another thing you think about in terms of the principles of design is, of the data that I have associated with a particular object, what's going to remain static when that object's created and what's going to be potentially change. And that's what gives you some insight about what some of the data, for example, that you can only get from an object, what some data that you can potentially set in the object, and if you think about what potentially uniquely identifies that object, what data do you actually need at the time that you construct the object. Right, to say this object is actually some particular unique thing that I care about. Okay? So let's turn that into a little bit of code just to make it a little more concrete. So we'll get rid of our friend PowerPoint, and we fire up our friend Clips. Oh, and look, a song, how convenient. So here's the information to keep track of a song. It's just a class called song, and what we want to do is keep track of the song's name, the band name, and the price. So when we create the song, one of the things we might do is say, hey, give me all that information to start with. Because if you're going to put some song in your store and you're going to sell it, it better have some song name and band name that I can use to refer to it by, because that's going to be its unique identifier, and give me some initial starting price. Now, we might necessarily not require an initial starting price because it's something that's going to change during the duration of the program and isn't part of our unique identifier. But in this case, we're just going to ask for an initial price. The thing we do care about in terms of the malleability of what's actually in this data structure is thinking about song name, band name, and price. So song name, we only have a getter for. There's no setter. Once the object's created, you can't change the band name for that song. You can't say, oh yeah, that was In Your Eyes by Peter Gabriel, and now it's going to be like In Your Eyes by Kanye West. Like, that's a different song, and I don't know if that's happened. It's probably not a good idea. But the song remains the same if you're a Led Zeppelin fan, right? And the band name, actually, the band name is also going to remain the same for that particular song. But the price has both a getter and a setter, right? Because it's something that's malleable. After we create that song, yeah, we might change its price, and because we know that, we provide both of those things in the definition of the class. Now, as we talked about in the days of yore, whenever you create a new class, it should also have a method called toString, and toString just returns a string representation of the data in that class. So this just prints out inside double quotes, which is why we have this / quote, that's a single double quote character, the title of the song in double quotes by the band name, and then it says costs, and it has the price associated with it that it costs. So it just returns a string that basically encapsulates the data. And here's the private instance variables of that particular class, right? There's a title, a band, and a price for the title of the song, the band that made the song, and the price of the song. And that's all the information that's in there. But it captures and encapsulates the notion of having a song and what parts of the song are static or can't change and what parts of the song are mutable or can change. Okay? So besides songs, we also have this thing called albums. Any question about the song portion? If you're sort of feeling good with song, nod your head. All right, good times. If you're not feeling good with song, shake your head. If you're awake, nod your head. There's a few heads that are not nodding, but that's okay. That's cool too. So let's do the class for an album. So the class for an album is another thing we care about. And albums become a little bit more interesting because an album not only has a name, right? So this is going to be a name, and yeah, the name will probably be some string. And there's also a band, potentially, that produces the album. Now, the interesting thing is the band, you might say, but Marin, isn't that redundant? Like, don't I have some album and it's going to have a bunch of songs on it, and so I already have names for the band for those songs, so why do I need the name of the band for the album? Anyone know? Want to venture a guess? Anyone have an album that looks like this? 80s compilation is the critical word, right? You can have an album that's band isn't actually a real band name. Its band name could just be something like compilation. And it's going to have a bunch of songs on it, each one of which has a distinct band. Okay? So that's perfectly fine. There's no reason why an album, especially in the online world when you can sort of create mixes all the time, needs to have a single band, and so there wouldn't be a need for having bands associated with songs. We still need to have bands associated with songs, and potentially we might at a high level want to be able to say, is this whole album by one band or one artist, or is it actually a compilation? Okay? Now the interesting part, though, is that an album not only has a band and a name, but it has a list of songs. So how might we keep track of that list of songs? What would be a reasonable data structure we could use? An array, our friend an array. Well, the only problem with an array is, right, it needs to have some fixed size. There are some albums out there that are very short, like In-A-Gadda-Da-Vida, Iron Butterfly. There's one song on it that's one side of the whole album. If you were back in the LP days of your end, what a fine album it is. And there's other albums that are just like, oh, look, there's like 300 songs on here. Okay? So an array with just a fixed size might potentially waste a lot of space. What's the more malleable version we could use? Oh yeah, I love it when it's just all around. All right, and now the social. I need to get a little bit of chocolate going, I think. It's like that post-Thanksgiving. It's like the tryptophan, still like working its way. Yeah, gotta get up. Build up an album to begin with. How do we actually say that this album has some list of songs on it? We need to have a way of being able to add songs to this album. And once we actually add songs to the list of songs on the album, we need to have some way of being able to list them out, or perhaps iterating over them, knowing that an array list implements the collection interface, so it actually provides you an iterator. Okay? So let's look at the code for that just real quickly, and then things will become more interesting afterwards. Right? So here's an album. Inside an album, we have an album name and a band. Those are the things that are going to start off by constructing an album. So we say, here's the initial album name and band, and what I want to do is build up the contents of that album. So I'll let you get the album name and get the band name, but you can't set them. Those things are fixed. Okay? The other thing that I'm actually going to assume here, which is something I didn't assume for songs, is that the name of the album is a unique identifier for the album. Okay? Because if I can potentially have compilation albums that's a compilation of multiple bands, so the band name is just something like a compilation, or maybe the band name is empty string, the album name by itself should be a unique identifier. Now you might say, but Marion, that's not true in the real world. I have multiple albums that have the same title on them. We're just going to assume that for the purposes of what we're doing here, and it'll be okay. How do we build up the album? We have a notion of adding a song to an album and getting an iterator over the songs on the album. And so the way we do that is we're going to have something called songs. Let me show you songs down here. Songs is just an array list of songs. Okay? And so if I want to add a song to the album, I pass it in an actual song object, and it adds it to its array list. And if I want to list out all of the songs that are on the album, I ask for an iterator over all the songs on the album. So what I actually get is an iterator over song objects. Okay? String just returns the title and the band. It doesn't actually list out all the songs. It just says, hey, it's just this name of this title and this band. And that's all that's in an album. Okay? Again, we think about what's mutable and what's not mutable. Now, to put the whole store together, right, this is where things get a little bit more interesting. To put the whole store together, you need to think about what's the store going to do. So let me show you the store running. And this is just the basic text interface for a store. It's kind of like online store circa 1995. Okay? So I can list out all the songs, I can list out all the albums, I can add a song, I can add an album. When the store starts, I have no songs or albums in the store. I need to add them all. I can list all the songs on a particular album, and I can also update the price for a song. Okay? So if I list out all the songs, it says all songs carried by the store and says nothing because there's no songs that the store currently has. And list out all the albums carried by the store and lists out nothing here because there's no albums. But I can go ahead and do something like add a song. And let's say the song I want to add is In Your Eyes. Peter Gabriel. Any Peter Gabriel fans out there? No? A little bit? Come on? Oh, man, I give up. It's all over. I just don't believe it. All right. We'll say the song's $1.90. Actually, okay, it'll be 99 cents. Go get it. All right, so we add a song, and if we list all the songs, now we have, here's the string representation of the song. In Your Eyes by Peter Gabriel cost 99 cents. We still have no albums, right? We just have a particular song that we could potentially sell by itself and we don't have any albums. And so we'll come back to this, but this is the basic idea. We want to be able to list all the songs and albums, add albums, and then list the information for a particular album. Okay? So if we think about that, what we need is a bigger data structure to keep track of all of this information about multiple songs and multiple albums. Okay? Now, if we want to manage an inventory, the two things we have to keep in mind are also what I mentioned before. A song can exist in our data that is not on any particular album. So as a result, it's not sufficient to just say what albums are carried by the store, because some songs may not be on any album, but we still sell them individually. So we need to have some notion of keeping track of a list of songs. Now, there's different things we could think of for a data structure to keep track of songs. One thing is an array list, right? That's what we're using in an album to keep track of a whole list of songs. Another thing we could consider is a hash map of songs. And so if we think about a map versus an array list, one of the questions that you want to think about gets back to this identifier question, right? Because if you want to have a map, say, for example, from string to song, and you want the string to uniquely identify a song, the string needs to be something that is a unique identifier. But a song doesn't have one string that's a unique identifier. Its unique identifier is a combination of a name and a band. And so all kinds of funky things, there's things that people consider, oh, why don't I concatenate those two strings together? People actually do that in real applications. We're not going to do that here. We're just going to say, there's too much complexity in dealing with this. We're going to go for a much simpler approach and just say we're going to have an array list of all of our songs and not worry about the unique identifier issue. So here we'd have an array list of type song, and we'll just call this songs. That's all the songs in our database. And so here we'd click create a new array list of song, and we call the constructor. Okay? Now, life in the album world is a little bit different. Besides just keeping track of a list of songs, we also need to keep track of albums. But in the album world, name is actually a unique identifier. And if we want to be able to look up albums quickly, it might make sense to use a hash map. And so part of doing this whole example is to actually show you both array list and hash map in one application. So what we could do is have a hash map that maps from strings to albums, where the map, the string, is in some sense the name of the album, and this is the actual album object. And we'll call this albums, and we could do all the new la-di-da hash map to actually create it. Okay, so now we have these two big data structures that actually keep track of stuff for us. Now here's where things get a little bit funky. And when things get funky, what you're going to need when you deal with big data structures, you need a guide. And you'll see this in just a second, because you're going to see some of the code that we write gets very long when we deal with big data structures. So I'll be your guide. All right? So in the days of yore, I almost brought the whole outfit, but it's a little hot in here under the lights. So in order to actually think about how do you get the information and store the information, when you have a large data structure, paper and pencil is your friend, right? If you spend all your time just staring at a computer screen, it doesn't allow you to internalize what does your data structure really look like and what's going on. So break out some pencil and paper, not right now, but when you're working on data structures, and draw out potentially what things look like. So here's songs, and song is an array list, and it's going to have multiple, let's say at this point, 3 songs in it. And over here we have albums, and albums is a hash map, albums, that maps from the names of an album to a particular album object. Now, the important thing to keep in mind in objects, and this is kind of the whole key to big data structures, is all objects, when you refer to them in Java, are references to objects. Remember when we talked about that? When you pass an object to a particular method or to a particular method in some application, you're passing a reference to the object. You're passing where that object lives. Okay? Which means that when you have an array list of songs, what you really have here are a bunch of references, which we can think of as pointers, that refer to the actual objects that contain the songs. Okay? So over here, here's In Your Eyes by Peter Gabriel, and it was 99 cents. And over here we might have, say, Ramble On. Tell me there's some Zeppelin fans out there. All right, good. We will not have to end lecture early. And Ramble On is just such a great song. It's like $12.99 by itself, single song. It's good. That's probably why most people don't listen to it. And over here we will have the master, Stairway to Heaven. Stairway to H. I'll just abbreviate because it's that good we have to have a moment of silence. Also by the mighty Led Zeppelin. And we'll just say that one should be like 49 cents so everyone can listen to it. It's just kind of like the bonus tune. All right? And so that's what we have in our list of songs. Now, here's the interesting part, right? If I'm going to have some albums, so I add some albums. So let's say I add some album on here like So by Peter Gabriel. And So actually has the song In Your Eyes on it. Okay? Now, there's two things that come up what we need to think about when we actually do this. We need to say, hey, this has got some array list associated in there, and so I could create a new object that is a song for In Your Eyes and set my array list to be a reference to that object. And that's a reasonable thing to do in some cases. The only problem is, what happens if I go into my store and say, hey, I want to change my song In Your Eyes from being 99 cents, because no one's heard of it before, to 9 cents. Okay? So if I go through my list of songs, I say, hey, oh, here it is. I'll change its cost to be 9 cents. Now, unless I go through all of my albums and find for every album, go through every song that's listed on the album and see if I can find that same song duplicated, I'm going to create an inconsistency in my data. What I really want to have is say, hey, there's only one object that is that song. And if that song happens to be a song that's sold individually, or it's a song that's both in my list of songs and on some albums, there's only one object ever that I refer to for that song. Which means I never create the second object out here for that same song. What I do is when I'm creating the album So, and someone tells me, oh, it's got the song In Your Eyes on it, I say, hey, does that already exist in my store? If it does exist in my store, I'm going to add that object to my array list. I'm not going to create a new object, which means each song only ever gets created once, but it can potentially get added to multiple array lists. And it's the same single underlying object that has multiple references to it. Why is that cool? That's cool because now when I come along and a whole bunch of people start listening to In Your Eyes and I'm like, oh, Peter Gabriel, he just deserves a lot more money. We're going to make this $9.99. It's $9.99 everywhere by changing it once. And that's the real key to large-scale software engineering, is you think about not only reusing, like for a long time we talked about having methods that you reuse and how you generalize your methods. This is about reusing your data. Thinking about your data sort of, if it's only one thing, exists in one place and everything refers to it. Okay? So any questions about that idea? This is what we refer to as a shallow copy. Because what you're getting after you've created that song once, when you want to add that song somewhere else, you're just setting a reference to it. You're creating a shallow copy. There's only one copy. The thing we did before where we actually created a whole separate structure is what's referred to as a deep copy. And sometimes deep copies make sense in some particular cases. Most of the time they actually, well, I won't say most of the time they don't. It depends on the application. But most of the time what you'll actually be using is your friend, the shallow copy. Okay? So what does that actually look like if we try to turn that into some code? Or what does that mean in the application? Let me show you what that means in the application. So we're going to add some songs. We're going to go through another example. All right, let me add the song in, I'll just abbreviate, In Your Eyes, Peter Gabriel, $1.99. Then I'm going to add Ramble On, Ramble On, Led Zeppelin, and we'll make that, oh, I don't know, $2.99. Okay? Now at this point I have two songs. Now I'm going to add an album. So I add a particular album. The album I'm going to add is So by Peter Gabriel, and it says enter a song name. It's going to have In Your Eyes on it. And it asks me, because the unique identifier is both the song and the band name, it still needs to ask me for the band name. And the band name I give it is Peter Gabriel. And it says, hey, that song is already in the store. It's just letting you know, hey, I found that song in my store, so when I add it to the album, I'm adding that same object that's also in my store to the album. And then you could say, well, there's other stuff on there, like there happens to be a tune called Red Rain, which is also by Peter Gabriel, and it's a fine tune, but let's just say it's 1 cent, okay? And it says new song added to the store. What did it do here? What it did in this case, it says, hey, you want to have a new song called Red Rain by Peter Gabriel. That song costs 1 cent. You want to add it to your album. Well, if you want to add it to your album, it's also a song that I'm going to sell in the store. So it actually adds it to the store and adds it to the album. And there's still only one copy of that object ever. It just needs to make sure that when it creates a new song to add to an album that isn't already in the store, it adds it to the store as well as to the album. If the song already exists in the store, then it just adds a reference to the album. Okay? That's the critical idea here. All right. So now if we sort of list, I'll put enter to quit, and if we list all the songs, right, the song Red Rain's now been added to the store and it cost 1 cent. And if I list all the albums, there's So by Peter Gabriel, and if I list all the songs on that album, it has the songs In Your Eyes and Red Rain, so it matches the picture that I think, right? That's why having a piece of paper where you draw pictures is useful, because you look at what your application is doing and you say, does it match what I actually think should be happening in my picture? And if it doesn't, then you know one of two things is wrong. Either your picture is wrong or your code that's supposed to be dealing with that picture is wrong. But in either case, you've already figured out a bug, even though the program hasn't crashed or anything, you just know there's an inconsistency. Okay? And so now if I update the price for a song, like I update the song In Your Eyes by Peter Gabriel, and I change its price to, I just go crazy. No one's going to buy the song anymore. It says price is updated. Now if I list all the songs, that song is $999.99 in the store. And if I also list the songs on any album, oops, 5, so lowercase, the price is also updated on each of the individual albums because there's only one object. Okay? That's where the consistency comes in. That's why the consistency is key. Okay? So what does this actually look like in terms of code? How do we do this? Let me show you what the actual application looks like for our little friend, the Flytoon store. Okay? So there's a bunch of stuff at the beginning that just asks for the user selection, basically prints some stuff out to allow you to make a selection, and then gets your selection for you. And then there's a big case statement that calls an appropriate method depending on what selection you made. So I'll go through some of the simple ones pretty quickly. You can list out all the songs carried in the store. In order to be able to do that, we need to keep track of how this information is actually stored. It's exactly in these data structures I just showed you. Song is kept track of in an array list of songs, and albums is kept track of in a hash map that maps from the name of the album to the actual album data structure itself. Okay? Any questions about that? Hopefully that's all clear. I will take off the hat. So how do we print these things out? To list all the songs, we just go through our array list up to its size. And this is why you want to think of data structures as you need a guide, because you're going on a journey. At any given point when you're dealing with a data structure, you want to think, what is the type I'm dealing with right now? What does that mean? It means when I want to print something out, what I need is a string to print out. How do I get a string? If I start at songs is an array list. I don't have a string I can print out. But from an array list, I can get an individual element. When I get an individual element of that array list, what do I have? I still don't have a string. I have a song. What can I ask the song for? I can ask to get the string version of the song, and now I have a string to print out. Okay? So you always want to think of it as you're going on a journey. Where do you start your journey? Your journey starts at the data structures you have available to you. In this case, we have a data structure called songs, another data structure called albums. That's what's available to us. And what we want to do is go from that starting point through a series of steps to get to the thing that we actually care about at the end, that little piece of data that we want to display or interact with somehow. So here's another example. If I want to list all the albums, how do I list all the albums? Well, to list all the albums is a hash set. So in order to do something with a hash set, I need to say, hey, I want an iterator over all the keys of that hash set. So albums is the hash set. I get the keys of the hash set, which is a collection, and I get an iterator for that collection, which is an iterator over all of the keys of the hash set. And now, as long as my album iterator, which is just my iterator over the keys, has a next element, what do? I start at albums. I need to say I need to get a particular album. Okay, get. Which album am I going to get? I'm going to get the album whose name is associated with the next elements of the iterator, right? Because it's an iterator over all the names of albums. So get gives me a particular album. Then when I have the particular album, I can call toString on it to get the string form of the album. Okay? Any questions about that? Because they're going to get even longer. So if there's any questions about sort of the chain of things we call, if it's making sense, the chain of things we call, nod your head. All right, and if it's not making sense, shake your head. And if it's kind of making sense, just keep looking and ask a question if a question comes to mind. All right? So how do I find a particular song? This is something where I'm going to use the helper method, so it's private, to find a particular song. Songs, their unique identifier is a combination of both the band name, or the name of the song, and the band name. So how do I check for that? I'm going to go through all my songs. It's an array list, so I can count through all the songs. Here's where things get long. how do I check to see if a song that's actually in my data set matches on its name with the name that's passed in? I start at songs, get the ith song. So now I have one particular song. For that particular object, I get the song name. Now I have a string. I want to check to see if that string is equals to the name that's passed in. Okay? And I do the same thing with band name. Song, get the ith song, get the band name of that song, and then check to see if that's equal to the band. And if both of these are equal, then hey, I found the song, and so I'm going to return an index, which is the index location of that song in my array list. And I can just break out of the for loop here, because once I find it, I say, hey, I found it. I don't need to keep looking. So this is one of the rare cases where you'll see a break in a for loop, is you don't need to finish the loop. You got to what you were looking for, and you get out of the loop. If you manage to get through this whole loop without ever finding something that matches on both the name and the band, well, your index remains -1. So you return -1 to indicate, hey, I didn't find it, because you know -1's not a valid index for an array list. So if you return it, that means you didn't find a valid element. Okay? How do we use find song? Here's how add song works. Okay? When you want to think about add song, you want to think about this property that we're only ever going to create an object once, and everything else are going to be references to that object. So the way add song is going to work is it's going to return a song object. Okay? And what it's going to do is it's going to ask us for the name of a song. If the user enters a blank line, that means they want to stop adding songs, so it just returns null to say, hey, you want to stop adding songs, I didn't create a new song, here's a null to indicate that you were done. But if they don't press enter the quit, I also ask for a band name, and then I ask to find the song. Okay? I call that find song method I just wrote, and I say, does that song exist? If the song exists, the song index is not going to be -1. And that means that song already exists in the store. So you told me to add a song that already existed in the store. So I'm not going to create a new song because there's already an object in the store that encapsulates all the information for that song. I will return to you a reference to that object, which means I just return from the song's array list whatever song happens to be at the index that that song actually lives at. Okay? So this just returns an actual object. It actually returns a reference. You can think of it as returning the pointer to the object. If I didn't find it in there, then hey, I need to create the new song, right? It's sort of like Red Rain at the end. You wanted to add a song, it didn't exist in the store. Let me get the price for that song. I'll create a new song object. And now here's the funky thing. I will add that song to my array list of songs for the whole store, write out to you that the new song was added to the store, and I'll return that new song to you so you can do whatever you want with it. And so now you might ask, okay, Maron, if I just added a song to the store, I don't really care about doing anything with that song. Why are you returning the song to me? And that's true. If I just add a song to the store, if that's all I care about, I ignore the return value. That's actually what I do up here, which is very funky, right? If you want to add a song, I just call the add song method. It goes ahead and adds a song to the store if it doesn't already exist, and it returns that song, a reference to that song object. If all I'm doing is adding a song, I don't care. I just ignore it. I don't assign it to anything. I just say, yeah, thanks for returning that object. That was fun. Yeah, whatever. And I just get rid of it. Okay? But the reason why I've written it this way is if I'm adding a song, if I'm adding an album, what do? I ask for the name of the album, and I check to see if that album is already in the store. If the album's already in the store, I'm not going to do anything because the album's already in the store. If the album is not already in the store, then I ask for the band name, and I create a new album. And then I put that album in the store. So albums is my hash set, or my hash map. I put in that hash map, the name of the album is going to be the key, and the actual album object is the object. So I add, the album so to my hash map. Now I'm going to add all the songs. So I have a while loop that goes through and keeps adding songs until I get a null from add song to indicate that the user wanted to stop adding songs. But here's the funky part. Every time the user adds a song, right, it comes along and says, hey, you want to create some new album. So let's say I actually want to create some new album over here when I create the album so. So none of this stuff exists yet. Okay? So it creates a new album. I say, hey, I want to create the album so. It says, okay, that's fine. Create an object for the album so. It has the name so. It's by Peter Gabriel. And it says, okay, what songs are going to be in there? And it starts asking me for songs because it's going to add them to my array list in here. And so the first song I say is In Your Eyes is on that album. It goes and says, hey, find that song. It already exists. It returns a reference to that song, which is a pointer. That reference is what gets added to my array list. Now I go and ask for another song. Do you have any more songs? I say, yeah, there's another song. The song is called Red Rain. When I go to create Red Rain, it comes up here to add song. Add song comes along, asks for the name and the band. It tries to find the song and says, hey, that song isn't already there, so I'm going to create a new song. It creates a new song called Red Rain by Peter Gabriel, has some price associated with it, and adds it to the list of songs for the store. And then it returns this object, which means it returns a reference to this object, and that reference to the object, oops, sorry, this got blocked, right? This is where it's creating a new song, and it adds the song to the store, right? It adds it to songs, which is that array list up there, and then it returns the object. So when it returns the object, I went too far, that object is not null. I add that song to the album. So this album, we're going to add a song, and the song we're going to add is that same object. It's Red Rain. Okay? So that's the important thing to keep in mind. That object's only created once, and we pass around references to it, or we can return references to it and assign them other places, and that's how you get consistency in a much bigger data structure. There's a bunch of other things we could do in here. I won't go through all the excruciating details down here, but we can list the songs on an album. We can update the song's price. And by updating a song's price, all we do is we ask for the song and the band. We find the song in the data set if it exists. If it doesn't exist, we just say, hey, it's not in the store. And if it does exist, then we read in its price. And then for the songs in the store, we find the song at that index and set its price. And we know that whatever other albums contain that particular song, if we happen to update the price over here to, $6.99, we only update it once, and all the places that refer to it automatically will see the updated version because they point to the same object. Okay? Any questions about that? So I know it's a lot of complexity to kind of deal with a big data structure like this, but now it's one of those things where it's like, now you're old enough to kind of see the big honking data structure. Because in the real world, when people think of software engineering in the large, these are the kinds of things they need to worry about, and that's where the complexity comes in, is keeping track of all of your objects and thinking about what objects you actually need to design and build in order to actually build an application that's kind of successful to keep track of and makes things consistent with all the data you have. So any other questions? Uh-huh.
So in this application,
Oh, can you use the mic, please? Sorry.
So in this application, do all the songs in the albums, they're also, I guess, singles, or because the albums don't have a price, right? It's just the individual
Right,
songs.
so the albums don't have a price. You could imagine the cost for an album is the total of all the songs on the album, or you could actually do something funky, right? That's one of those places where you can make a policy decision and say an album is 90% of the cost of all the songs on it. And then all the individual song prices can change, and at any time you just say, what's the price of the album? Total up the price of all the songs and take 90% of that. So it also allows for very dynamic album pricing too. Alrighty, if there's any more questions, come on up. Otherwise, I'll see you on Wednesday.